Hello, welcome to my demonstration for the software engineering Solitaire game. So I've launched my game. You can see we've got our logo, cards been dealt, shuffled, we've got 24 cards left over in the draw pile. We've got our lanes 1 to 7, and we've got our diamonds, hearts, clubs and spades foundations. We can have lane 1 there has 6 of diamonds, just the 1 card. Lane 2 has a 7 of hearts and then an unknown card below it, and so on. Lane 3 has 1 card and 2 unknown cards. So I'm just going to show off some invalid moves first before I start making any valid moves, just to show off that we have error checking in this. So 1, 2, I can't move 6 of diamonds to a 7 of hearts. It's because they're both red cards. And I will try 4, 6, 7 of clubs to 3 of diamonds. Can't do that because the ranks are incompatible. Try to move into a foundation, you can't do that because they have to start with an ace. So 1, 4, we can see we got our 2 cards together now in pile 4. A 7 of clubs and 6 of diamonds together, and it gave us 5 points for that with 1 move. If I draw a card, I got an ace of clubs, so now I can move that from the pile into the clubs foundation. That gave us another 10 points. Draw again, I got a queen of hearts. Draw again, and you can see I have this sort of a stack, a first in, first out type thing with these. You can draw up to 3 and then it'll start replacing the cards the more you draw. If you aren't sure what move you want to make, you can use question mark, it'll print out the rules for you. And I think at this point I'd like to demonstrate a win condition, so instead of just playing the game over and over until I happen to get a win, I'm just going to force a win by generating some cards sort of arbitrarily. So here we are now. I've generated all these cards in the foundations. Each one is filled with 13 cards except for the last pile there, the spades. The cards themselves there are immaterial. Obviously there would be checking. You wouldn't be able to fill them all with cards of the same rank in reality, but just for demo purposes I'll do that. And then I have one more spade 7s. Move it in and there you go. We get 20 points for moving from a lane into a foundation, and congratulations, you won. You can type P to play again and the game is just initialized over again for you. So next up I just want to go through the structure of the code as quickly as I can. So we've got our main. First thing that happens inside main, we get this init, and that will print out the logo, print your rules. You'll initialize a new deck, new scanner, get the lanes, pass into the deck, create a new board which receives deck and lanes. Set the game state to active and then initialize your score and move count to 0. Once the game is in an active state, we're in this while loop, checking for a win condition and receiving user input, converting the input into a char array and then receiving each of the characters individually. I'd say most of the action here happens within the board itself in the move card function. So we'll look at that next. The board, actually maybe we might go into the pile instead, because the pile is probably the most important class. Yeah, so in this, the pile is it's the data structure that pretty much makes everything. The foundations, the lanes and the draw cards are all made up of piles. The pile is pretty much just a wrapper around array list, except it has this hash set for keeping track of unique combinations of cards. It just receives cards as an array list, and then it takes this card label to identify which pile we're dealing with. You instantiate the card, just pass in a label on the cards, or we have this other constructor where you can pass in an integer, and it'll pass that into a character instead. Obviously, because some of them use numbers, some of them use letters. We got a lot of methods which are pretty much just array list methods. Add cards just has some extra checking around a normal add method. Add multiple is the same. We have remove multiple. We're always checking for unique card combinations as well to make sure that the user doesn't just pass cards back and forth. We have validation based on the order in the lanes and the order in the foundations. We check that every time before we move a card. Make sure that cards in the lanes are in alternate, followed by red and black or black and red. We want to make sure that the piles have the suits that we expect based on that list of suits that we have up there. Finally, we always want to check as well that the ranks on the cards match up with what we expect. So we're checking for color, rank, and foundation to make sure that they are in the order we expect. In the board, then, the board I suppose is the main sort of class defined in the game. We have this drawn from deck, which is, these are your cards left over from the deck after it's been shuffled. There'll be 24 of them. You instantiate this board, you pass in the deck itself, and you pass in the lanes. We do that in main. It gets the deck after the cards have been shuffled, and that's how it instantiates the drawn from deck array list. And we create these foundations in the constructor too. This find pile is very important because obviously we pass around locations based on characters, so we need to have this method to figure out what pile somebody's trying to target based on the character they send in. Drawn from deck, I already discussed that one. This is that kind of first in first out thing I was mentioning, how it'll start to replace the cards in that order. Checking for unique combinations. Move card, obviously this one is a very big function. As you're saying, we pass in our positions based on characters, so we have to figure out which pile they want to move from and which pile they want to move to, how many cards they want to move. So there we figure out the start pile and end pile. And we have all sorts of validation, like making sure that there's a card below the card that we're trying to place to determine whether the card below it needs to be flipped. We validate the order of the cards in here, obviously, to make sure that the user is trying to make a valid move. Again, checking for unique foundations or unique combinations. And then we'll have a look at I suppose we've looked at all the classes now, so I just have one more, which is the tests. I was testing tests I had weren't really the best. I was more or less just testing this by playing it as I went along, and then realised that that wasn't the best approach, so I wrote some unit tests. I have sort of three sets of them, where I set up the standard game and I test the standard game to make sure that we have 24 cards left over from the pile after it's shuffled. Make sure that the lanes have the expected number of cards and that we have the expected number of lanes and the expected number of cards in the lanes. Generate dummy foundations. I use that one to test the win condition, just to make sure, fill each of the foundations with their 13 cards and see if we reach a win condition based on that, as we should. So when I set up the win condition, generate dummy foundations, and then check if the game state changes to 1, which it does. Finally, I have test card movement. This kind of does three things. It tests whether you can move cards between lanes, cards from the lanes to the foundations, and whether you can move multiple cards. That's reflected in all these different assertions I have down here. So I have one making sure that it doesn't go ahead when it shouldn't, making sure it receives the expected amount of points when it makes these various moves. And I think that's probably pretty much it. Hopefully this explanation was enough. Thank you for watching.